rather wait till the end of today's meeting. Oh, yep. Today's meeting is recorded, as you can see. And if you would like to ask us some questions, definitely go ahead and ask them in the chat section, or you can just wait till the end of the meeting and we would have a Q&A session so you could ask some of the question in person. Well, I think we're all ready to begin. So I will ask Mgo to tell a little bit about himself and start with his meeting.
Yeah, sure. Hi, everyone. I hope you can hear me clearly. Okay, sure. Let's go. Let me share my screen and I will tell you about the presentation, a little bit about myself. Okay, as you see, the presentation is called Skeleton of React, and there is some gibberish thing here. This is my name, actually. It has a lot of letters, not many vowels. Actually, my parents were actually convinced they're gonna try to actually punish people by making my name harder. So that's why they did it. I don't know. So this is my name. Okay, I'm super excited and I'm super anxious right now because like stereotypically, like many other developers, I'm a little bit introverted person. So I do good in small circles, but at large circles, I'm a mess. But due to this webinar, I think I'm gonna do good because I can only see 5 people at my screen. So psychologically, it's good. So okay, let's move on. Okay, who am I? I'm Magirdish Minasyan, and you can call me by my short name, Mago, or some people, like my Russian colleagues, call me Mgo to make it easier or catchier. I'm a front-end developer here at Provectus. I've been working here for 2 months or 3 months right now. I'm a newcomer. So okay, I'm gonna tell you a small story about myself, and then we can move on to our presentation. As I was actually preparing for this presentation, I was doing some researchers. I was a bit anxious because the topic was a bit too much for me, and I was pacing down my house incessantly, like because I didn't know what to do. I was pacing up and down, up and down. I was going and coming, and suddenly I actually touched a plate, and the plate fell on the ground, and I catched it in the mid-air. And I realized the plate was broken and I injured my finger. I had to go to the ER and do some stitches. And while the doctor was doing the stitches, like many other developers, I was doing some optimization in my head. Like I said, okay, I can work with one hand, but it will be twice as low. It will take two times the time. But that was an underestimation, like all my tasks. And that's it, I guess. Let's dive in. Okay, I'm gonna give you a disclaimer on this one. You have to buckle yourself up, brace for the impact, because this is an abstract topic. This is an abstract dive. This will not teach you how to write a better React, but React is written in such a way that you don't have to understand the inner structure, how it is written, but you can write it in more optimized way by using the design pattern that the React team is actually telling us to do, like composition over inheritance, or do not use mix-in or use custom hooks, for example, because those are actually experimented over the years and they have design patterns that we can actually use in order to make React more optimizable. But this talk is not about that. This talk is about the inner structure of React, how React as a team actually built its library so dynamically that we can use it across many platforms. This will help you to understand the general architecture. And for me, this is the most important thing, because in my opinion, programming languages and libraries will come and go, but the general architecture and the algorithms stay the same. So back in the 1960s and 1980s, if I'm not mistaken, IBM, when you used to use COBOL programming language in order to write some, for example, operating systems and some computational things, but they use algorithms and data structures that we use today. But that language, for example, now it's not much more relevant today, but the general architecture is the same. So now when you understand the general architecture, you become a much more better developer. And that's why we're here, right? To learn new things and become much more better software developers. And you will see more diagrams than code. From my personal experience, I will tell you that seeing a diagram, it will be much more intuitive. And because you will not actually capture the code, you have to read the code in order to understand what's going on. And reading someone else's code is much more slower than reading your own. So if you understand the general architecture, you can actually implement it on your own. You don't have any problem in that. So let's move on. Why investigate the structure in the first place? Like, why do it? Why skeleton of React? Why actually take React apart to understand it? My philosophy here is this. Like, for example, if you want to understand something, take it apart. Like, for example, a young kid, for example, he gets a new toy, let's say a car. He will actually take the car apart in order to understand what's going on underneath. There's an antenna and there's a battery and there is this some green thing that does that. He will break the antenna. He will realize he cannot not actually move the car with the remote control. Then he will actually realize that, oh, okay, the remote control used to connect via the antenna via these things called waves, and the car will actually work from there. So when he actually broke the car, in the process, he learned something new. And since I'm working with React and version control management, I will not be able to break React. If I did something wrong, I can just clone the library again and start from scratch. So I will actually, the philosophy here is this: break it apart, take it apart to understand how it works, right? Okay, deeper understanding of the mental model for reusing it in the purpose of the future. For example, not only front-end developers can actually benefit from this, the back-end developers and other people that are interested in the architecture do too, because when you understand the general concept of it, you can reuse it in your project and modify it a little bit and reuse it in your project. And it is much more beneficial that way. And the third point is a simple one: curiosity. I'm a curious guy. I work with this library for a long time. I like to think how it works, right? Okay, let's move on. So what is React? React, like most of the programming languages and a library, it is built for a reason, right? It is built for a specific reason in mind. Some projects output numbers. Some other projects output strings, right? And React with its algorithm output a tree. It will actually do some heavy computation and it will actually give you a tree, and you can actually use this tree to draw a UI. So that's what all React does. It will take an input and will actually output a tree for you. So what the core of it constitutes of, right? Okay, the first one is the host tree. The second one, host instance. Third one, renderers. Fourth, the entry point. And the fifth is the reconciler. Okay, this will sound a bit more abstract right now, but I'm genuinely, I swear it will pay off once we actually understand each one of them on its own, and then we will actually have the mental model of how all of it is actually connected together. Okay, let's start with the first one, host tree, right? Host tree is a type of tree that represents the UI. Like every UI structure in mind, it should be represented as a tree because it is much more efficient that way. So a tree like a DOM tree that we see in the browser or an iOS hierarchy, every host tree has its own imperative UI. Every host tree has its own functions to manipulate that host tree. For example, the DOM tree have a set of functions that is related to the browser that you can actually manipulate, remove, add, actually add some color, manipulate the DOM tree in one sense. And for example, the Apple Swift API has add subview. It has its special or declarative UI, imperative UI that you can actually manipulate its own host tree. So this is the host tree on one hand. Then what is React is used for? It helps you to manipulate complex host trees in response to events, timers. So every host tree has its own event and timers, and every host tree will provide the React with these events and timers. So React can actually work with those event and timers to update something on that specific host tree. For example, React can work with the browser or with the React Native or with an SVG renderer or in the terminal, right? And every one of those renderers have their own events and timers that are specific to that environment. and they will provide the React with these events and timers, and React will do those manipulations regularly according to those events and timers. It will expect the host environment to be stable and regular. And those are much more abstract than it is. Like, for example, it actually expect everything to be consistent. Like, for example, if you had a button in the UI, and if you click the button and the whole tree actually collapse, it is not a consistent UI. You should actually have a consistent output for every the same set of input that you do, because there are a type of programs that are called 3D pipelines that actually give us chaotic versions of an output. Those kind of programs, we cannot actually plug in React into those because they are much more chaotic. But the one that we work with every day are much more regular, and we can actually plug in the library React with it and reuse the React algorithm to actually output some kind of tree. So another thing to see here is the host instance. So what is a host instance? Host tree consists of nodes. Because it's a tree, it has nodes, right? And every node is a host instances. Like, for example, in the DOM environment, you can create a host instance by actually calling the DOM environment create element. It will create a DOM node. And for example, in the Android, it could be unique values identifying native views from JavaScript. So you will call a function from JavaScript that will go and build your Android view for you, for example. But each one of those host instances, they have their special properties, right? Because in the DOM environment, you will have the DOM and the DOM node, and these DOM nodes has set of properties and attributes that actually explains to the DOM node what to view, what to actually render, what to draw. For example, when you want to actually change the color in the DOM environment, you will do DOM node .style.class, and you will actually .style.color, and you will actually change the color. And if you want to do the same thing on Android, Android has a different property that you can actually automatically change the color without calling the style. So how does React know that the DOM node has this extra attribute, but the Android does not? That's an interesting question that we're gonna come back to in the upcoming slides. So this is a general recap of both of this. Like, we have the host tree, and then we have a tree of host instances because it's a tree. And wait, sorry. Okay, you have to excuse me. You have the host tree of host instances, and you have the host instance itself. So the host instance is a subset of the host tree itself. So the renderers, now we are getting into juicy parts, right? The renderers actually teaches React how to talk to a specific host environment. The renderer teaches React to talk with the browser environment. It teaches React, another renderer teaches React to talk with an Android environment. Another renderer teaches React to actually talk with an SVG renderer, a terminal renderer. Like, we have much more renderers to name, like the React DOM, React Native, and the React Inc. Those are the popular ones. And you can create your own renderer with an experimental package that React created. Like, for example, you have an environment that you actually want to integrate React into. You can use this experimental package that React provides, which actually expects from you a set of functions to actually write. For example, a set of functions like adding a child, removing a child, mutating something on the child, adding a sibling. Those set of functions that is related to your host environment, you will actually put it in your renderer, and the renderer will actually give to the React those set of functions. This is the first link. The renderer provide React. So what does this mean? The renderer teaches React to talk with a host environment. How does it teaches React to talk with a specific host environment? React actually requires from the renderer to provide him with a set of functions, And that set of functions React will use to actually update an host environment or an host instance, right? So React is actually wanting a renderer to have something like of a host config where you can actually place all your functions, and React will take those functions and reuse it in its source code. So the fourth point, I think this is the most easy one, which is the entry point, right? We all know of this, because when you call, the first thing that is being called from the React, the React project that you are initializing, is the React DOM.render. Here I use the version 17, but it's the same thing with the create root and render. Here we have the host instance and the React tree and the renderer. So renderer is calling the first function ever to start all of its process, to actually generalize the tree and the host instance, and then to put the tree inside the host instances. But technically renderer is not doing that. Renderer is actually calling something that's called the reconciler. So when React actually published version 0.12, they wrote everything together. So they wrote the algorithm together and they wrote the DOM part together. But then they realized they can actually refactor those three in order to use the same tree in the native as well. So what they did, they actually separated React into these 5 parts, right? You have the React API that we use state, use reducer, set state, and the components. Then you have the renderer to talk with the host environment. And then you have the reconciler function, that actually does the rendering and the diffing part. It's the process of figuring out what to do with your host instances. Like if something changes, how it should change it. If, for example, the div change into a span, how to change it. The reconciler is the one doing the juicy stuff, is the actual algorithms that React wrote. So back in the days, we have 2 types of reconciler. The first one is called stack reconciler, that people call it the virtual DOM. And nowadays we don't have it. We have the fiber reconciler. So because React actually generalized the reconciler and the React API and the renderer, they actually easily updated the reconciler function and put something new in it, because the code is modular in some way. So how does this fiber reconciler works? This is a topic on its own, but I'm going to give you a general overview of it in order to have an idea how does this thing works. The general algorithm of the fiber is separated into 2 parts. The first part is the render part, which is an asynchronous. And the second part is the commit part, which is synchronous. So why is the render asynchronous and the commit synchronous? React realized that they had a huge bottleneck issue when they were actually rendering a huge trees on the stack reconciler, because the tree was actually, during the processing of this JavaScript code, was blocking the event loop of the browser. So React has to think of a way to actually pause this process and actually process something from the browser and start doing that job from where it left off. So that's when the renderer comes in. The render part actually does the diffing part. It actually takes the tree, create a new tree in progress, and it has a time lapse where actually it is cooperating with the browser to see if it has time to actually draw something. And this thing is called the work loop. And this is actually asynchronous, where it asks the browser, do I have time to draw this? The browser says, okay, you have time. Then the React does some of the re-rendering and the diffing part. It doesn't actually commit something to the DOM. It just does diffing. And then when time ends, it will go to the browser, and you will not see any lags, because the browser event loop, it happens so fastly, but because you didn't notice. And the browser will actually will send another request to the React, and React will see if it has higher priority, it will process that first. If it does not, it will actually continue the render of the previous tree that it was doing. And after it finished the rendering part, it will go to the commit part. The commit part is actually where you commit your changes to the browser, where you can actually see those changes in the browser. How does the 3D change? The fiber structure will actually keep a tag of them. It will actually go and compare the trees, and every node that is changed, it will put a label on it like a sticker. So React will know on the commit phase it was changed, and it will go and re-render all of those on the DOM or the environment, the host environment that you are hosting, and play all of those lifecycle hooks that we love or hate, depends on your uptake on this. So the render is the diffing and the creation of the new fiber tree, and the commit is actually applying those changes to the UI. I know this will sound a much more abstract. I'm saying the reconciler things it should be a subject on its own, but in order to give you a brief preview on this one, that's why I included it here. So the reconciler, so that's the thing that actually I was stuck on for 2 or 3 days. The reconciler actually is included in the renderer package. For example, it gets initialized with a specific host configs in the renderers. So in the renderer, like I said, renderer should give React a set of functions that React reconciler will use during the update and render to draw something on the screen. So the renderer job, React DOM job, or React Native job is just to give React those set of functions. And it is very easy to create your own renderer. You just have to provide those set of functions. And it is about 20 or 30 functions, which is pretty easy thing to do. So how all of this is connected together? Let's recap. So we have two graphs here, React Native and React for web. As you see from the top, React API is shared by both of those, and then you have the renderer, like React DOM renderer that actually have inside of it the React reconciler function, the main algorithm for React, and the DOM API, which is the host config. And the same thing goes for the React Native. React Native renderer has the same React reconciler, but different host configs for iOS and Android. So only the host config is changing. They are using the exact same React API, the exact same reconciler API, just with actually changing minor functions in the native view of the host environment. They are able to manipulate those complex UI on those different platforms. Let me recap it again. So React API has an entry point that actually calls a renderer. A renderer has a host config, which is a set of functions that React expects a renderer to have in order to render on that specific host environment. And that renderer also includes a package called the reconciler, which is the actual algorithms behind all of those React. Technically, the renderer during the initial render calls create container and update container, which are both functions from the reconciler that actually schedule an update on the fiber, and all of it starts from there. As you see, it will get initialized from the host config, and then it will render an update. Let me recap that again. So the reconciler during the initial render, it will schedule a render on the fiber, and then fiber will draw this, because fiber knows how to draw on a specific host environment from set of functions that the renderer provided to the reconciler. And then the second thing that we have to think about is how to re-trigger those changes by set states and effects. How does reconciler knows about set state? Because set state, you include set state from the React API. Then if you go through the source code, you will see nothing written in it. They are actually calling a functions from the React reconciler itself. And then React reconciler during the set state actually is calling a function called enqueue state. They are actually enqueuing all of your changes inside a queue. and this is their batching algorithms to batch many renders together in order to optimize your changes. So it will call an enqueue state, and then from that, the same enqueue state, it will actually schedule an update on the fiber, the same schedule update on the fiber that during the initial render it was called. So it is the same function called from different places in order to start the diffing algorithm. And I am saying this about the batching because all of us use React Redux, right? And React Redux actually does the render and commit phase on every dispatch. And that's why the React Redux team actually provided us with a batch function that you can actually batch your dispatches inside a single render, and then you can actually commit all of those inside a single commit. So if you have a large tree, it makes sense to batch those in order to not re-trigger the tree on every dispatch. And that's React is doing for us. And another thing here is that with the new React 18 version, you can actually, the set status will be dispatched from the timers as well, because we didn't have that functionality. And now with the fiber, we do. Another thing that we have from the fiber is that you can actually, because you can actually pause the renderer, you can actually give a priorities to the renderers. So if you had a small render that has high priority, it will actually stop the last one, and it will process the higher priority, which has a smaller timestamp. It will commit those changes and then continue your tree. So it is much more efficient this way. And because of the new structure, they were able to do that. But before they couldn't. So conclusion, we're finally here. So congratulations, you made it through. So what have we learned? The general architecture, I hope, foundational knowledge for more in-depth dives, and React source code honestly is not organized. I've been actually diving through those, and everything you see is with functions. They have no general structure, no prototypal inheritance, no class modularity. For example, they use a file system name with some name, and they export a function in it with another name. But the core algorithms is so good, they can actually dismiss those minor things that they did. Actually, my friend was telling me about this thing that maybe they did it on purpose in order to make the algorithm, in order to make the structure harder for you to understand. And once you understand it, you will be worth actually working with them. I don't know about this. I think it sounds like a conspiracy. We can move on. Okay, Q&A, go ahead, ask me questions. And this is a QR. You can actually get the slides. I will try answer your question honestly. And if I don't know something, we can actually work through it. I guess you can ping me on Slack and we can go through the code. Go ahead.
So guys, who would like to go first with the first question?
I have a question.
Cool.
Yeah, go. Could you please describe this maybe in a few words? This a system of priorities in a reconciler. Only the size of the operation, or how it works? Who decide that the operation is more have higher priority?
Sure. React in its source code in the fiber has 5 types of priorities. Synchronous, which is exactly used to work like an old stack reconciler, has a higher priority, medium priority, and low priority. For example, when you use hooks like use transition in order to actually make something's priority higher, so you are actually telling React that this next rendering has higher priority. So it has a property in it, which is the priority, and it will actually check the priority of this render with the previous render tree that it was doing. If it has a higher priority, it will put it in the front of the queue, and it will re-render and commit those changes before the last one. Is it clear?
Yeah. Thank you.
Cool. Thank you so much. Anybody else? If you don't have any possibility to ask a question, you can chat us a question and we would be very happy to answer it.
And one thing to add, and when I said that you can actually initialize the renderer with a specific configs, React actually has two modes. One is a mutation and another is persistent mode. And mutation works in some environment better. Like mutation, you don't create a new thing, you actually mutate. In the DOM, it is much more efficient to work with the mutation because it works in a mutation. But in the React Native, it's much more efficient to work in a persistent mode, and the persistent mode actually clones every new node, and it makes a new instance, and you will use that instance. And because of the multi-threading in React Native on Java platforms, you can actually get use of those use cases, I guess.
Cool. Anybody else would like to? Oh, all right. We have Roman who thanks you for the talk. So that's good. Feedback is always good. Great.
Yeah, I have one more question. Yeah. So I see that we have like no question from our guys. I want to say thank you, Ngo. That was like awesome. And I think it's a good start to let's say series of lectures that can help us better understand the work of like front-end frameworks. Maybe you have in your head the like raw list of the topics related to React, which we can cover next time.
Yes, I have another great one in mind. If you guys want an abstract one, we can do on Fiber how it works, the algorithm with demonstrations. And if you want a more reusable one in our everyday daily projects, we can do higher order components, or using custom hooks versus higher order components, or how to actually write React in such a way to minimize the re-rendering. Whatever suits the guys, we can actually do a poll and decide what do they actually want.
All right, I'm going to then squeeze a little ad in the talk. As Ngo just mentioned that he has a couple more ideas. Maybe some of you also have a couple more ideas with which you can, of course, do your own demo day and tell us more about the things that excite you. And we would be very happy to help you from our side, from the learning development specialists side. We will be very happy to support you with this process. So in case you would like to become like Ngo and tell us more about the things that excite you and made you feel wonderful about this topic, please reach out to us and we'll be very happy to help you and assist you with this wonderful journey for Demo Day. All right, and maybe somebody has a new question? Maybe.
Yeah, I think I do. Thank you for your presentation. It's really interesting. And the question is, how do you think, how many major changes does React 18 has? I mean, for what reason do we need to migrate on it?
Well, can you repeat the last thing again?
My question about the React 18 version, does it has some, I mean, major changes, some changes that you need to use to upgrade your project? Maybe some, I don't know.
Yeah.
Some changes that will make your application much more easier to manage or something.
Yeah, like I said, because let's look at this with the timeline, right? They released the Fiber with the version 16.8, if I'm not mistaken. We had the version 17, which is stabilizing it, and then now version 18. And in the version 17, we had some experimental features like suspense and concurrent mode. And those actually help us to re-render the tree partially because of the fiber structure. And when we actually re-render the tree partially, you will actually, it will load faster in the browser, and you don't have to go all of the tree to re-render in the browser. And in the React 18, you have the couple of hooks, use transition and other hooks that actually you can give priority to your re-renders, right? And when you give priority to your re-renders, you are actually telling the browser, this thing is much more important than this one. Please draw this one before this one. So you have more control on what to do with your re-renders, and thus greater user experience. And they have a nice documentation and other features that they have added. I think there are 4 or 5 hooks that they added that you can look through in the React source code documentation.
I just saw that the guys on the Kafka UI project already migrated to React 18 version.
Yeah.
So I just wondering how it can be hard to migrate all the project to React 18. Does it has any problems?
Migrating a current project that
Yeah.
And we had one issue in the Kafka UI team is actually to migrate the jest, because the enzyme, because we used enzyme and we use React testing library, and React testing library works very greatly with React 18, but the enzyme renderer, we didn't have it and it wasn't working correctly. So we migrated the enzyme to the React testing library, and then everything else works okay. It depends on your project and what kind of dependencies that you use.
Yeah, because I already wanted to try React 18 on my project, but the main question was like, what happened with what will happen with tests? Because the test, the first thing that you face with is the following of a test. Sometimes you're really afraid of it. So I think your answer is answering my question.
Yeah, they maintain everything. They added a couple of features because enzyme doesn't have a renderer for React 18 yet, and it didn't have renderer for React 17. There was another person that actually wrote a renderer, and that's why it's much more better to React testing library, and it's much more it is much more, the API is much more declarative. You are testing it like a user, and it's very integrate. I got a block right now. It is much more easy to use with React 18. This is some of the references that I use. Of course, the React source code is important, and there are 4 great articles. One of it was written by Dan Abramov, the co-creator of Redux, and the 2 of them was from GitHub, and another one was from their documentation. And you can follow me on GitHub and LinkedIn, and you can ping me whenever you want on Slack. I will help you anything with the source code, because I've been reading through it these 2 weeks. So
yeah, and I believe we will share the record and the presentation in About Frontend channel. Guys, please join to have the feedback and maybe ask questions. Yeah, thank you. Go.
Sure.
All right, maybe some other questions.
Should I ask some questions?
No, maybe people have some other questions. No, I don't think so. I think it was very clear. All right. And we have more people who are saying thank you for the presentation. And yeah, thank you so much, everyone, for joining. I think that would be it. We will definitely send you the recording of today's meeting, and definitely reach out to Mugo for any further questions you might have in the future, and reach out to us in case you would like to have some support with the preparation for your own demo day. Thank you so much, everyone, and have a wonderful rest of the day.
Have a nice day, everyone.
Bye-bye.
Thank you very much.
Thank you.
Bye.
Thank you so much. Bye-bye.